Welcome back to EMW's Filter channel, and today we have a certain kind of topic which has aroused our interest during the COVID pandemic situation. These are terminologies which we use more and more, for example aerosols, particles, or also indoor air quality, for example in office buildings, are getting more and more important for us. So it makes sense to understand these terminologies with a certain kind of standardized definition. Let's start with the definition of aerosols, and the origin of that word goes back to the ancient Greek and the words there which stands for air and solution. And according to the standard DIN EN ISO 29464, an aerosol is a system of liquid or solid particles suspended in gas. I know that was quite theoretical now, but to make it more practical for you, we have here prepared a small animation. Now you can see in the animation the structure of such a system of an aerosol, and such an aerosol is, for example, the ambient air, and the system here shows you pretty much that we talk about millions of liquid or solid particles which can be part of such an aerosol. So the next word we talk about is particles, and as you have seen in an aerosol we talk about liquid or solid particles. And what you can see here right now is I'm representing the solid part, and surrounding me is a liquid part. And let's say when we have the constellation that in an office building, due to discussions which are going on, or if somebody cough or sneeze, for example, there can be of course a bunch of particles getting into the atmosphere of such an office building. And for example, what is a particle distribution? Usually we would refer to, we talk about particle sizes of 0.5 to 100 micrometer. Let's talk about a situation which we usually have indoor with regards to humidity and air velocity. Then we can say that the liquid part of a particle, especially for very tiny particles, can evaporate within seconds. Whereas with larger particles, like here 100 micrometer, we can talk about that the evaporative effects can take minutes. The final point we want to talk with you is about how much time does it actually take for a particle to sink down. And therefore let's talk about a standardized situation indoor, where we talk about that the particle has to sink down 2 meters and the density of the particle is comparable to water. Then we could say for a particle size of 100 micrometer that it takes round about 8 seconds to sink down. Whereas if I now shrink as a particle down to 10 micrometer due to evaporative effects, for example, then it takes already several minutes till I sink down. And if we talk about particles of, for example, 1 micrometer, then we can easily say we talk about approximately 16 hours till the particle sinks down to ground. So that's all about aerosols and particles, and as you have seen, it's very important to have the same definition in mind so that there's the same understanding for this kind of terminology. And when it comes to, for example, indoor air quality, what you have to see is that especially a liquid part of a particle can easily evaporate, and then we talk about different particle sizes and a different behavior, how the particles sink down to ground. And accordingly, very important is that you have always to think about the right filter solution for your application. And I would say if you want to hear more about filtration technology, just follow us on YouTube, stay tuned on our LinkedIn channel, and then we're gonna see each other next time.